So my name is Michael Stahnke. I'm going to be talking about DevOps today. And if you don't know a lot about DevOps, that's okay, because we're going to start with what I think people know, and then we're going to go through how it actually works, and then we'll get back to what you'll actually care about. So a little bit about this presentation. I've given it a few different times at a few different venues. Sometimes it's been in front of an audience of 400 people, and sometimes it's been in front of 4. So I like to talk about DevOps. I like to talk about how you can learn from working with others and working with DevOps. So this is just another opportunity to do that. So I was very happy when they asked me to do this. A little bit about me. My background's largely in the server space. I worked in server architecture, I worked in automation and tool building, and I worked as a system administrator. Those were the things I did prior to coming to Puppet Labs. Basically, I have always been fascinated by automation, and of course, working at Puppet Labs, an automation company, was really just kind of the cap of that entire story arc. That, for me, worked very well. In other areas that I've been involved with, I'm very active in the open source community. I founded a package repository called EPEL that you may have heard of. I founded that with 6 other people, both inside and outside of Red Hat. They were a team of people that wanted to make the experience of working on Red Hat Enterprise Linux more usable, I guess is a good way to put it. So we put a bunch of new packages together, and that package repository still exists today. Also in around 2005, I wrote a book on SSH. And that was because I was very interested in SSH and using it for automation at the time. Today, that book is quite outdated, and so it's not really worth purchasing unless you just want to give me royalties. And if you do, I appreciate it. So I guess I'll start with kind of just the mantra of how an operations person works. And that is that it's really 100% impossible to exceed expectations. The expectations that everybody has upon an operations person is that their services are available 100% of the time. Now, in most areas, you can do better than what people expect. In operations, you absolutely cannot. You cannot get better than 100% uptime. It's either up or it's down. It's working or it's not. Kind of the corollary to this is that no one ever got a high five for the server staying online. No one ever appreciates the operations people for things working exactly the way they're designed or the way they're supposed to, or preventing that outage that no one ever knew could have happened. Basically what happens is people work very hard to, at best, meet expectations. However, nearly all the time you cannot meet expectations because 100% uptime is basically impossible. So, when I was kind of thinking about this, I was starting to read a lot about DevOps. And this was in, I'm going to say 2009. When I really started to read about this thing called DevOps. There was a talk that had just happened called DevOps Days, and it was in Belgium, I think. And it was the first one. And I was just reading about this, and I was sad that I couldn't be there. And then kind of it just blew up on the internet. And there was talk on Twitter, there was talk on LinkedIn, there was talk on everything that I could read about was DevOps, DevOps, DevOps. And what it basically came down to was there was these people that were doing things very differently. And they were doing 10 deploys a day, which was just unheard of at the time. Deploying your website 10 times a day or deploying your product 10 times a day was crazy talk. Most of us came from an enterprise background where deploying twice a year was considered quite a feat. But the way that they talked about, they were always, we have these rock stars that we work with, and we have these rock star ninjas. And then, you just start reading the one ads. It was ninjas and rock stars, and eventually there were pirates thrown in there, and there were other things that were just kind of silly. And there was just lots of press and lots of hype. And I felt like eventually it kind of got to be this echo chamber where the top few people were talking to each other, basically, rather than talking to an audience to broaden it. And I didn't really know if it applied to me. I worked in Middle America, flyover country. I wasn't in New York. I wasn't in the Bay. And so to me, this DevOps stuff was really interesting, but it just didn't seem like it fit to what I was doing. And so, I read about it and I think about it and kind of just pushed it aside and thought, okay, we are not a group of people that writes our own tools. We do not have this awesome application development team. We were a group of people that did back office IT for a company that was trying to make a ton of money and keep the stock price high. That was basically the goal of the company I was at. And that's very different than I want to be the best at technology. So the entire DevOps mindset just didn't work. Now to set the stage, like I said, I was at a large company with competing priorities. What was really large about this company was it was a company of over 100,000 people. The division I was in was about 1,200 people at the time. And the IT teams didn't even all sit in the same building. And so for us, I was on the server team, and that server team had been basically exiled to a different building because they got along so well with everyone else. And so that was kind of what happened. At the company, the average time in your role was 2 to 3 years, which meant that if you didn't move on in 2 or 3 years, you were kind of seen as dead weight. And what that meant to me was that we were a company that was, 85 years old, but we had about 3 years of experience overall. And that didn't work very well. You didn't have a lot of deep expertise in a lot of areas, and you didn't have a lot of just people being very good at the things they did in IT. They were very well they were able to dabble in many, many things, but not really be good at any of them. We also didn't have developers. We used purchased applications nearly exclusively. Sometimes they were developed by people outside. We would pay a third party to develop something if it was custom, but we didn't really have any developers in our own staff. We had application owners. And as far as I could tell, the job of an application owner was to pick up the phone and connect the server administrator with the vendor who wrote the software, and the application owner. Their job was basically to be the bridge conduit between those two people. I guess it was a good gig if you could get it. And then the other thing was, what you would say about these application owners is that they were really nice. Everybody was really nice. And that was basically the best compliment you could pay them, because you weren't going to find anything having to do with technology to compliment them about. Basically, they kind of knew what a computer was, but they were just very nice people. Unfortunately, this didn't work very well for us wanting to be very good at technology and deploy faster and work harder. So, kind of for us, like I said, the application owners would call the vendors. And when we would end up taking this purchase software and customizing it for our needs very, very heavily. Customization leads to, of course, known problems. One of them is upgrades can be extremely difficult, which means a lot of times you're stuck on a version of software that is 3, 4, 5, 8 years old, and you're asking for custom patches or custom security updates if you decide to apply them at any time. So it was just kind of this stale place to work. And success was basically measured in terms of lack of change. Anytime you change something, there's a possibility that it breaks. If you don't change anything, the prevailing theory was that it would not break. And for us, that was very challenging because we couldn't improve things very quickly. You couldn't improve what you couldn't change, but if you couldn't change things, things would still break in the exact same ways. And so for us, that was very difficult. And the change control process was much more about approvals than actually about making sure that we were going to make the correct change or improve anything in the infrastructure. It was much more of a control point to make sure that the right people had signed off on the right amount of paperwork and the right division manager approval and all those kinds of things. We didn't really have time to really work on anything else. We didn't have time to debate better ways of doing things or different ways of doing things. It was just a matter of you need to not touch these servers, but when they go down, it is your fault. And so that was kind of setting the stage of the environment that we were in. We had a lot of enterprise-y tools, and I guess you've probably heard of a few of these, but things from BMC and CA and IBM were all very common. At the end, I remember saying that it felt like if you had to say the letters of the company, you were allowed to buy it. But if it was an actual word that you could say out loud, we weren't allowed to buy that kind of software. And so, I work at Puppet Labs now. I was not allowed to buy a tool from Puppet Labs because it wasn't sold by IBM or CA or BMC. So I had to use competing products, and in many cases. We were very large in the Oracle and IBM space. So we had Oracle RAC and Oracle EBS. And if you've had to use those, I apologize. I usually don't put those on my resume because it means I have to do those again. WebSphere and MQ Series and WebLogic and all those kinds of application servers were also there from IBM. And again, those are challenging to work with, but it's a pretty common stack that I think a lot of enterprises have to work with. We also had a lot of heterogeneity in the operating systems. So we had HPUX, we had Solaris, we had AIX, we had RHEL, and then we had VMware ESX underneath some of that. And that was growing rapidly throughout my time there. So as you can see, this was kind of just a hodgepodge of a lot of stuff to manage and a lot of different goals with the restrictions and handcuffs of not being able to change very much to start with. So there was a small team in this division, and there was a small team and 4 people quit. And that was what happened. So it was a team of, I think it was a team of 7, and 4 people had quit, and I was in a different division at the time. And they basically called me up and said, hey, do you want to come run this team, or do you want to come be on this team because we kind of need people? And I said, sure, why not? It sounded like a nice challenge, I guess is the right way to put it. Information here was definitely tribal. And when half of your tribe leaves, a lot of information's gone. You have to figure out, how are you going to learn what these people did? What did they work on? How did they work on it? One of the best administrators that I ended up meeting there learned a lot of what happened by literally logging into the servers and looking at shell history and looking at what commands were being run most often. How did backups get performed? Well, I'll look at the shell history. How does this application get restarted? I'll look at this shell history because it wasn't written down anywhere. And this same person was taking 16-hour days usually at work because they were down 4 people on that team. And so he was working as much as he could. I remember the story. I met his kids once, and his daughter was playing out in the yard and said, this little spider's going to work, and this little spider's staying home with mom. And I said, well, why is the spider going to work? And he said, well, that's what dads do. And I said, but it's Saturday. And she said, well, but it's Saturday. He's going to go to work. And so that was just kind of the understanding that team had at the time was, you were going to work lots and lots of hours. And beyond that, this team was blamed for everything. I already said that they were kind of this put in exile across at a different building across town. There was this, I think it was either, I don't know, it was around 10-floor building. It was, a spectacular, mid-rise kind of building that had marble floors and all this. That was the main building. And then there was this little data center where the server team sat that was, just in a nondescript commercial park with cubicle walls. And it was just very different culture. But that was where the server team got. The server team was blamed for everything. So if your database had problems, blame the server team. If your application didn't work, you'd blame the server team. If Obama won an election, you could probably blame the server team. So the other thing with this team is, remember earlier I talked about how every 2 or 3 years people wanted to rotate jobs. That was the best thing for your career. Well, no one ever asked to transfer onto this team. People only asked to get off of this team. And again, it was because of these reasons that, they were exiled to a different building. They didn't get along well. They were blamed for people. A bunch of people had quit. So when I say server team here, I really mean the Unix team. There was a Windows team as well, but the Windows team and the Unix team didn't talk. They were basically mortal enemies at this point. And then there was also a storage team, which was doing enterprise storage, fiber channel and large system arrays. This was mostly backed with IBM storage at the time. So these 3 teams were eventually kind of exiled to this different building because they needed room at the main office. At least that was the excuse they gave. And it was interesting. I didn't mind. But I took the job. And, a lot of people ask, well, when you set it up like that, why would you ever take that job? And I'll tell you, the reasons that I was interested in it were I wanted to get better experience. I knew this team really had nowhere to go but up. And they were using a lot of open source tooling. So earlier I talked about how, we had to use things from IBM or BMC or CA. And that was the company mantra. And that was kind of where the architecture committees were sending you. And that was where the software purchasing guidelines would lead you down. But this team just didn't care about that. And so they just started running a bunch of open source software because they thought it could get their jobs done better. They had an LDAP directory for all the authentication, which the rest of the company didn't have. They had CF Engine running for their configuration management. They had Nagios for their monitoring framework rather than a multi-million-dollar Tivoli installation. Basically, they were doing everything against the grain for that company, and that was very, very appealing to me, even though they were still hated by everyone. My goal was basically just to be the best sysadmin out there. I wanted to learn a ton. I wanted to learn about the tools that were out there, and I wanted to just be better. And so that was why I came to this job. I knew it wasn't going to be the simplest thing in the world, but I really didn't know what I was getting into either. Obviously, a lot of this I can look at in hindsight and say, well, this is what was wrong and this is what was wrong. At the time, it would just seem like, okay, they've got some problems, but there's a lot of opportunities here and it'll be fun. The bonus for me was also that being on the other side of town, the traffic was way better to get there than down where the main building was. But in the end, I really had no idea what I was doing. When I got there, I just kind of, learned what was going on, learned about 16-hour days and, learned about reading shell history to figure out what was going on in a lot of cases. And that was kind of scary. So databases, they were kind of the thing that I started with there. And that was because if your data layer doesn't work, none of the rest of your applications are really all that important. If you can't serve out the data, the applications are just skeletons with no real content. And we had a lot of different database issues. We had a lot of variants. So we had, I think it was about 25 database servers, which isn't a gigantic amount, but it wasn't a small amount. And I think we had 24 unique configurations across 25 servers, which means that only 2 of them were actually configured the same way. And we had at least 6 clusters in there, which meant that the items in the same cluster were not configured the same way, which, as you can imagine, resulted in all of the availability that you would expect when a cluster is not configured the same way across multiple nodes. Like I said, things were going down often. So I got there and I kind of did that analysis and figured out that we had 24 different types of configurations and was kind of shocked. And this picture sums up my feelings without using any expletives. So my manager at the time was a big proponent of Six Sigma. To me, Six Sigma had always been a collection of funny belts and a bunch of words, and it was almost like a cult, and it really didn't solve any problems for what I was trying to work on with computers. But she was really able to boil it down to me into terms that I did understand. Math was never something I shied away from. So she was basically like, this is all about quality control, and you need to reduce your standard deviation and then raise the mean. And what that really meant was understand what's going wrong, make it go wrong in predictable ways, and then fix the ways it's going wrong. If it's going wrong in 45 ways, your defects are going to be very hard to reduce. If it's going wrong in 4 ways and you understand what those 4 are, you will have a much easier time reducing your defects. And so that was basically the best summary I ever got of Six Sigma, and that's really all I've taken away since then from Six Sigma. And so this comes down to my first kind of idea of how I was going to succeed with this team, and that's to reduce variability. Less variability means that I can understand what's going on. And to me, that was reducing variability in server configurations, in database configurations, in the number of platforms I was supporting. Early on, we really tried to get HPUX out of the environment completely. One less if statement in every process is one less opportunity for failure. So for me, it was really about reducing variability. And so you might ask yourself at this point, I thought at the beginning of the conversation you said you were going to talk about DevOps. Well, I am. And the thing that's really important to understand about DevOps is that you want to work culturally with your own team and work outward. For me, DevOps can start at the CIO, it can start at the CEO, but then it's much more pushed down, and it's not really the culture movement that you want to be successful. So to me, it's much more about working with your team and your team, kind of your peers on other teams, to be successful. And we're going to talk about that through each one of these methods. But the first one, reducing variability, is just something very simple that you can do to be more successful. And this doesn't only apply to being on servers. If you're a network administrator or you're a storage administrator or really you're an infrastructure at all, that could include databases or middleware, less variability is going to be easier to manage at all times. So standardize and automate is kind of what you can do to reduce that variability. Automation comes way, way easier when you have fewer if statements to code around. So the next thing that I got to with those databases, I'm going to keep coming back to this database story because it was a large part of my year, I think in 2008 or 2009, was I wanted to make changes to get those things into a more known state. Those servers were, like I said, in 24 different configurations, and I wanted them to be in, 1 or 2 configurations that I could easily understand. That required downtime, and I got a lot of pushback on that. And they said, look, we can't take outages on this stuff. We can't take this kind of downtime. And I basically came back with, you're having downtime now. Do you want me to make it productive or not? You're going to have failures. You are having failures. And so basically we can have planned downtime or unplanned downtime, but either way, your availability is not going to be at the 100% mark that you're hoping for. And, while it sounds like kind of a cocky attitude to have toward working with management, it actually won. They eventually kind of understood. They were like, yeah, we are going to have problems. And so I'd rather have problems that we plan rather than the problems that are just going to happen. So as a result of trying to reduce the variability here, we started failing in known ways. And this meant that I wasn't failing because of weird configuration in a kernel parameter, or I wasn't failing because something was set up in an oddball skew. It was failing because, things were actually wrong in the overall configuration, whether it was firmware management or it was disk layout. But it was actually things that were kind of repeatable across the system. So if something was wrong on one system, they ended up being wrong on many, many systems, which meant that one fix paid large dividends. So fewer configurations and better uptime happened. And kind of as I started doing analysis of what was going on with these database servers, storage management basically ended up being being the root cause for a lot of what was left in the failures. And this isn't to say that the storage team was terrible or anything like that. It was just kind of the way we had provisioned the disks and the way we had set up things on these database servers was just all over the place. Whether it was, it seemed like we just made up a new way to put disk on these servers every day. And so lots of tickets were on disk management. So the database administrators just kept coming back and saying, this disk management stuff is killing us. And I agreed. And so I decided, to work with them. And they said, what if we did our own disk management stuff? And I said, wait, hold on. You guys can't have root. I'm the server team. You're the database team. You're the application team. But we just started talking more and more about it. And eventually we got to the point where I did want them to have root. And I did want them to be able to make these mistakes or work or improve things. And so I started delegating out with Sudo many, many things. And eventually they just got rights to do basically everything on the system. And this scared a lot of people. A lot of my teams that thought that this was basically me just giving up and saying, okay, the server team's, we might as well be out of a job because the database team can do their own administration or will be doing their own administration, and they're going to do it wrong. And I agreed with that. They were going to do it wrong, but I wasn't that concerned about that and the outcome for the greater good. What this led to was kind of a shared responsibility for outages. And so if something broke, because you can't tell whose fault it is right away when it breaks, it was basically the first task was, let's get everybody on the phone or online to work on this problem together. So if the systems team noticed a problem first, they'd call the database team. If the database team noticed the problem first, they'd call the systems team. And so we were working together on the outages. And this actually led to shorter outage times and faster resolution because you had a larger breadth of expertise available working on the problem. This also led to properly classifying systems. I don't know what your data centers are like, but I found that teams often classify things as production that are not actually production. Or they call, this test thing actually is production because it was running on this guy's laptop, but eventually it started being used for more important things. So we moved it onto the server and we never told anybody and it didn't have any monitoring or backups, but it's really important. If it's down, we're going to call you and wake you up in the middle of the night. I think that's a pretty common story for data centers. But we adopted this policy that was, if I'm awake, you're awake. And so that meant that if you were calling me at 2 a.m., the first thing I was going to do was call you. So, if your monitoring system alerted me and said, hey, this system's down, even if it said it was test, I was going to call you and make sure you were out of bed. And the reason for that is it does help you classify your systems properly. And if I only have to take care of 12 database servers at night instead of 25 because some of them are test or some of them are development, that's better. That makes everybody's life better. So sharing the pain here kind of allowed for a better classification system and working together in a more tangible way for results. And, did we give up rights on our systems? Yeah, we did. But in the end, I think it led to the database team being able to provision their own disks and set up the disks the way they wanted. And it also did allow them to make mistakes, and we had to help with that at times, and they helped us with our layout mistakes as well. So collaboration to me was really about sharing the pain. And the other thing that I really learned was if somebody is carrying a page or is not carrying a pager, their decisions are influenced by very different criteria than if someone is carrying a pager. And of course, I'll say pager, but the on-call rotation, whatever it is, your pager duty setup. For a while in the different business unit I worked in, we had a team that was called basically the implementation team. And their job was to do setup and planning and architecture and design of systems, and then it would hand it over to the operations team. The problem was the implementation team didn't carry a pager. And so they would come up with the most complicated solutions for things that would page us at all hours of the night on the operations team. And that just made me so mad. And eventually when they did have to carry a pager, it turned out a lot of their solutions became a lot simpler. So it's just a very important thing to keep in mind that if your people making your decisions are not carrying a pager, question what their criteria are for success. From an operational perspective, I want to make sure that I'm alerted as little as possible, or when I am alerted, it's a real problem. It's not just something that I can just hit, never mind, I'll look at it in the morning. So kind of method number 2 here was stop, collaborate, and listen, because like all good people, I take my advice from Vanilla Ice. So basically, it's taking your silos and removing them. The database team and the server team in this example really didn't get along very well to start with. They were kind of at odds with each other. They were blaming each other for outages. The management team for both of those teams really was at odds with each other, blaming each other for outages. And in the end, getting us all in a room, sitting down with, well, what's your big pain, whiteboarding it out, and realizing that, just delegating responsibility to both teams in some cases was going to fix the problem was a huge, huge win. We thought about replicating this with other teams in other ways, and it worked well with some teams and did not work very well with others. Certain teams have very different motivation for what to keep available. They think that uptime is important, but only important if it's your problem and not theirs. It just kind of matters what the team is. Luckily, at the database level, people usually have enough system exposure that they very much understand kind of the problems of where they're at in the stack. Some other teams that didn't work as well with, but I do think that it's worth the conversation with all of those teams to figure out where's their pain and how can you help. Another thing you can do is kind of bring in ops early into your application lifecycle. So whether that's a purchased product or you're developing stuff, you want to make sure that the operations team has a say in how it's deployed and how it's built. And part of that is because of that whole pager factor of getting paged when you don't want to. But it's also they can help with kind of designs they've seen work. One of the interesting things about most operations teams is they're cross-cutting. They get to service many, many different application teams. And so they can see what worked well for other application teams. And maybe the application team you're working with hasn't deployed an application on this type of technology before, but another team has. And so the operations team can say, here's how this other team works. Here's the way they do it. And you can learn a lot from that operations team because they're just kind of very much generalists across the board here, and they're cross-cutting. So bringing your ops engineers early will usually have benefits. And so then you get to blame. Blame is it's a big part in corporate culture, I guess, and that's why people always want to make sure it's not their fault. That's why you have the whole people, making sure that they try and CYA on their emails and things like that. Do I have this in writing? Things like that. Blame is really, really important, and I wish it wasn't, but blame is very real. And so for us, we used to always talk about blame storming, which was figuring out how you're going to make sure it wasn't your fault. But in the end, when you did have an outage, because outages were still happening, they weren't necessarily, we hadn't solved all problems at this point. You have root cause analysis meetings, and that's usually led by, some kind of ITIL framework where they go into either 5 whys or what happened. Can we get a postmortem on this action or after action reviews? They're called a lot of different things, but in the end, you want to know really what happened. And they always state that the first line there was, we're not here to assign blame, but that's absolutely what they were there to do, was assign blame and make sure it wasn't going to happen again. The making sure it wasn't going to happen again part is the important part. The blame part is just kind of there. And so you have what's the root cause and what was the impact and how do we do this to not happen again? What do we do to make it not happen again? That's kind of the structure for nearly any type of postmortem or root cause analysis. So you want to make sure that you're appropriately passing the buck, blame storming appropriately so it's not your fault. That's not at all actually what you want to do. What we did, we had a major outage, and this was, again, a storage outage, and I don't mean to keep picking on the storage guys. They're just, when the storage goes down, it impacts a ton of people. We had a storage outage where we had misconfigured an array. It was actually zoned to 2 different areas, and one of them kept overriding the other one, and it took us a long time to figure out, probably 6 or 7 hours to figure out what was going on. And, we walked into that after action review meeting, and it was scheduled for 2 hours, which was twice as long as it normally is. And everybody was kind of just hanging their heads on the ground, and you could tell that people were upset. People were clenching their knuckles on the table, and they were upset. We had lost some business, we had lost some money, and so I walked in there with my team, and we had built a timeline basically of what had happened, what we had tried, what we had done, how we were going to fix it in the future, and basically stood up and said, "This is all our fault. Here's what the problem was. Here was the safeguard that was missing. The safeguard's now in place. Here are the new monitoring tools that we put in place to fix this kind of thing." And we handed out these little sheets that had the timeline and what was all of our discussion, and we walked out of there in 15 minutes. And that was the shortest after-action review I was ever in. And it was really because we just stood up and said, yep, that one's on us. We screwed that up. Here's why it won't happen again. And, so we just said we failed. We totally messed it up. We're sorry. But we're not, we're human. We're not all these machines. The machines do what we tell them to. And so, that was a real big turning point for the team. I think at that point, several other teams kind of had a lot more respect for the server team at that point, where 1, you could stand up and say, yes, this was us. And 2, here's a detailed plan of how it's not going to happen again. it just kind of built some credibility with those teams. And, we had to drive across town to go to that meeting, by the way, just because we were on the other side of town. But so shouting your failures and really just owning up to your problems, I think is very big. And in certain cultures, this is extremely tough to do. Your corporate culture may be not rewarding of this type of behavior. Ours certainly wasn't, but I wasn't willing to just stand there and try and pass the buck and say that it was the storage team and not the server team. We were on the same team, or that it was, well, if we hadn't bought that stupid stuff from IBM and we had bought the stuff from EMC or whatever, it would have been fine. And, all of that was just what if, and that wasn't real. And so you also want to make sure that you're kind of learning from each of your failures. And I know that kind of goes without saying, but I want to make sure that I do hit on it a little bit. And that's, catalog the types of failures you have so that you're not failing in the same ways over and over again. Nothing's more frustrating than dealing with the same outage twice. And so that's really kind of where that comes from. This also goes back to the first point of, reducing your variability so that you can fail in ways that you understand and then prevent them. So in my root cause analysis meetings, I basically shouted my failures, and we had a written out report of the timeline, what happened, when it happened, what the remediation plan was. And like I said, it was, a 10, 15-minute meeting. We were able to walk out. We had 2 hours scheduled. What I was able to do was take a long lunch that day. But it's just a good idea to kind of have these things ready rather than sit there and try and take the abuse from other teams if they're going to dish it out. And again, this is a corporate culture thing. Some cultures are very good at this, and others are very much about blame storming. So at this point, we've had some success. We've reduced some variability. We've had better uptimes. We've had a couple outages here and there. But everything is certainly not better overnight. I was on this team for 3.5 or 4 years, really, working with them. And things were certainly, years ahead of where they were when I left from when I started. And it wasn't just me. I obviously had a team of good people that we were able to bring in and work with. But as time passes, you have new issues. You have new types of failures. And, some of these failures I love to just sit there and talk about crazy things I've seen in data centers and, people that have messed up or made big mistakes, and we all have them. But one of my favorites on this one, I am going to share it just because I think it's hilarious, was we had a guy who exported his home directory via NFS to every server in the data center, which was awesome until he closed his laptop and took it home and left a stale mount on every one of the systems. And of course, a lot of monitoring tools run DF to check for disk free space, and that means it hangs because that file system is not found. So we basically were spinning CPUs and hanging monitoring on 400 or 500 servers all at once because one guy decided to do something that was a convenience method for him. And so that happens. We fixed it. The other thing was we had this kind of configuration management mess. And this was interesting because, like I said, when we got there, I knew that they were using CF Engine. What I didn't know was there was this other tool called ISConf that was also in the works there. And so ISConf was actually even older than CF Engine in some ways. It's a dialect of Make, basically, that can build systems. And that was calling CF Engine in some cases, and CF Engine was calling back to it for other cases. And so there was just this web of entanglement of how do systems get configured. And it got weirder and weirder as you went off of Linux. Basically, the Linux stuff we understood and it made sense, but you went to Solaris, it got pretty crazy. You went to HPUX, and you were just lost as to how things worked or if they worked. And so, these things still existed. I couldn't tackle them all at once. It wasn't my biggest problem. It wasn't causing me the most pain. So things weren't perfect, but we were trying to still improve. So this also led to experiments. What things can you do to improve on those failures? You're going to have failures, but how do you improve them? One of the things that I really was doing, and this was kind of where, again, I went back to that DevOps reading that I had been doing, was trying to apply Agile processes to infrastructure. And this was a very new thing, I think, in 2008 or 2009. How do I take Agile development, the Agile manifesto, and apply it to teams that are basically working ticket queues for problems or doing architecture, configuration and availability design? Very different things than writing code. I'm not sitting there with a customer daily and iterating and having a prototype and having them give me feedback on it. But what I was doing was working tickets very closely with customers and getting feedback on those. I was designing availability and finding out what types of availability they cared about. Was it disaster recovery was more important than resiliency? Was fault tolerance more important than active-active? I mean, there was a lot of different questions for how things worked. So we tried doing Agile infrastructure stuff, and I started reading about, what was there for Agile infrastructure. Around this same time, I met a guy named Luke Knies, and he had this tool called Puppet that I had heard of a little bit from the Fedora project earlier. But when I lived in Nashville, he lived in Nashville, and so I ended up meeting him out for beers with a few other people that we mutually knew, and that was how I met him. And he was talking about Puppet, and I just thought that this tool sounded like a better tool than what I was using between this ISConf and CF Engine mess, trying to configure my systems. So I got to start playing with that, and that was written in Ruby, which meant I got to learn a new language, which was Ruby. I had done a lot of Perl and a lot of Python, but Ruby sounded interesting, so why not? We also kind of broke into Scrum teams where we'd have a daily stand-up in the morning to kind of talk about what were we hoping to accomplish that day. And, stand-ups vary in quality, and ours varied greatly. For a while, we could get the whole thing done in 6 minutes. And other times, if we had a stand-up where with a couple teams, sometimes a couple times a week, where the Windows team would join us or the storage team would join us. And sometimes that would be 35 minutes because I swear people want to tell their life stories every morning. But it was also very helpful in knowing what things were blocking other people, and you could collaborate on very quickly after the stand-up and say, oh, I hear you're having problems with this thing. Let me help you with this. I have a script that does that already. You can just fix it up and deploy it, and you'll be fine. So I think there was a lot to learn there. And then I also had other experiments that completely failed. For a while, I wrote a tool that I thought was going to take inventory of all of our servers so I could figure out all the hardware statistics and what was going on and what our capacity measurements were. And it was just going to SSH out and grab all this information and then store it all in subversions so that I had a version repository of it. And in the end, that was just a terrible idea. It worked horribly. But if the cost of failure isn't high, you can move pretty quickly. And I think that's pretty important. So my cost of failure was I was out my time. I didn't hurt anybody. I didn't cause any availability problems. I basically just uninstalled the thing that I had written and decided it just wasn't going to work for the use cases I had in mind. So I guess in this case, while you're still going to have problems, the freedom to experiment is very important. If you cannot experiment and try new things, one, you're not going to learn, which means you're not going to be happy. I think it's been proven time and time again that learning is the thing that makes most people happiest. If they're doing the same thing over and over again, they're generally not that engaged in their job. So learning and education mattered a lot to me and mattered a lot to the team. So if they weren't allowed to experiment with new things, they weren't learning new things. So that was really important from just a personal engagement level. The other thing was there's a better way to do things than the way you're doing it today. It might be 10% better. It might be 300% better, but you don't know until you start to play with it and try it out. And for us, the better things were, okay, I'm not going to have 3 configuration management tools. I'm going to move down to 1. Or I'm not going to have 4 ways of monitoring systems. I'm going to have 1 that works. And I'm not going to page off of non-production stuff at night. It was just things like that. We're going to experiment. Some of the things that I thought were going to be complete failures that I kind of hacked together to solve a really quick problem ended up being in production for years. And that was because they really solved the problem and were more efficient. We had an issue where we wanted the help desk to actually take over our password resets and account management. And I wrote this quick little thing, I think it was in PHP, God bless us, to put this all together. And I thought, okay, this will work for a couple weeks until I have time to do something better. And it ended up, somebody put some CSS on it and make it look a little prettier. And it was a self-service application now for, an accounting department of several hundred people. And they just loved it. They thought it was the greatest thing ever. And emailed them a one-time token to go reset their passwords. And they just never had these problems again. And I really expected it to be a big failure. I expected it to have more integration points and have more checkpoints, but it worked out fine. And again, that's kind of the fun of the experiment is if you know the outcome, it's really not an experiment. If you don't know the outcome, you can learn. And keep in mind that a failed experiment is still a valid experiment. An experiment where you get a negative result doesn't mean the experiment wasn't successful. You've learned something. You've learned something that doesn't work or maybe isn't the right thing at your company or your culture. But it doesn't mean that it's bad. And, at the end of the year when you have to review your goals or your accomplishments, I challenge you actually put a failure on there because that'll bring up an interesting discussion with your management team. And this also means that you do need kind of areas to experiment safely. Having development and environments for the tooling is important. And a lot of people are very willing to purchase development environments for applications. Everybody has a development database cluster, or they have development WebSphere environments. Do you have a development environment where your operations team can just go mess with stuff? It seems like that often gets cut from budget. Buying a second $700,000 storage array is kind of expensive for development. So what do you do with it? Well, maybe you have one that's less important or only serves out storage to other people's development instances so that if it goes down, it's less of an impact. Or maybe you buy, the $150,000 budget one that's very similar. It just depends on how you need to operate there. But it is important to make sure that you have the tooling and opportunity to experiment as an operations engineer. And again, this doesn't just apply to servers or storage. This is in networking, or if you're in database, or if you're in middleware, really anywhere in the IT stack. Experimentation is important. So kind of at this time, it was, well, in a control phase, what do we do? We're feeling pretty good. We've reduced our outages. We're having fun. We're experimenting with things. We're learning new things. Well, for me, it was all about finding what was the biggest pain point. How do I make the goal of, I want to sit around, do nothing, and have things alert me when they're broken? That way I have time to experiment with things I want to play with all day long. And that was my goal. I didn't ever quite get there. But it was find the biggest pain points. And pain to me was measured in terms of time. It wasn't necessarily what was the most difficult. It was what was the most time consuming. And every month I would go through our tickets that were resolved, and it'd usually be between 200 and 300 tickets, and figure out what, group them. What kind of themes could I get out of all of them? And I would start trying to tackle whatever the largest quantity of tickets was. So like that first time, it was account management. And that was when I hacked up that little self-password reset thing. And that took care of about half of all the account management tickets. And, a couple months later, I was looking at it, and it turned out to be printer queues. And yes, printer queues still exist, and they're all over the place. And they care about if it's duplex or half duplex and what size paper it is and all those kinds of things. When you have accounting applications, that stuff really matters. And, so we started writing some automation around print queue setup and, what language was it going to print out in, and, did it need Unicode or not? All those kinds of things. And that reduced our ticket queue by another, 30 or 40 tickets a month. And so you just kind of keep working through that. And I think by the end, we were averaging around 150 tickets a month instead of around, between 200 and 300 a month. That's better. It was less time spent. And it was just a process that we kept repeating. And some months it looked like, you had a scatter plot of just things all over the place. You really didn't have a good grouping of things. And so you basically just pick something and be like, all right, let's just try and work on this thing and hope that it pays off. And sometimes it would, and sometimes it wouldn't. The other thing here, though, is as we started worrying about how fast we could provision new servers and infrastructure to our customers, and our customers were all internal at this point, we started figuring out what can I fix. And provisioning used to take, 6 weeks, something like that. We ended up writing a thing to do self-service server requesting where it would, route for approval. And once your manager approved it, we could either start building the thing right away, or it could automatically build it if it was in VMware. And this was, kind of the early days of using the VMware API, using the Perl CLI tools. So we just started writing things like that, and we got it down to where, it might be 4 hours from start to finish when you request a system. And that was a whole lot better than 6 weeks. And what we found was, the database team was pretty excited about this, and we realized that they had a giant backlog of installing an Oracle client on all these systems. And that might take another 2 weeks just to get the Oracle client installed. And so we talked to them about maybe we should just include that in the build, or just make it a checkbox when you order the system. If you say, I need an Oracle client, we'll just put a checkbox on there. Because basically, while we had optimized the time of the build overall from going from 6 weeks down to, a few hours, if you still had to wait 2 weeks to get that system to use, to the end user, it still felt like it was a 2-week process. It didn't matter that the server team was very quick and that the database team was slow on this end. And this was just one of those examples of we improved something, but it wasn't necessarily the full bottleneck or the biggest bottleneck in all cases. And if you improve things that aren't the bigger bottleneck, it's kind of wasted effort. We ended up adding a checkbox into our server provisioning system where you could just say, yes, I'd like an Oracle client. And that just applied a Puppet class, which allowed it to just automate, pull down the Oracle client, install it, and it was all set up and ready to go during the handoff. So again, now it was a 4-hour process or a half an hour process or whatever it was. It kept getting shorter and shorter over time as we would fix whatever was taking forever. And this was also our first example of being able to drive value up the stack. I found it very difficult to try and get budget and get basically buy-in from other teams when I was in infrastructure. Basically, the applications kind of ruled the world because they interacted directly with customers. People could buy products, or people could, set up a new loan, or whatever it was they needed to do. At the infrastructure level, it was just there to do that. It was just there to enable those kinds of things. And so when I wanted to do things, I had to make sure that I could specify that in terms of value for the customer. And so that was things like pairing with the database team to say, hey, we're going to install this Oracle client for you. And that meant that the database team now had less work, which meant that somebody else was happy because they could go spend time tuning indexes on, things that mattered for customers. And so driving value up the stack was something that we learned a little bit later, but it was definitely important, of pairing with the people above you to drive automation there, whether that's automating application installs or application setups or code deployments or whatever had to happen. We were happy to do that so that we could get funding basically for the things that we wanted to do. Puppet was kind of not even talked about until eventually one of the application managers came over and said, hey, I've heard about this thing called Puppet, and I've heard that it's helping my database team. What can you tell me about it? And, so that was a great conversation to have of, it's this tool that's automating your installations for your Oracle client. It can, it's setting up all your users ahead of time so they're built the same way every time. And that was just a really neat thing to do. And again, I didn't have to go get funding from my team because there was another team that was very much into what it could do. And that meant that they were going to go on my behalf when the budget time came and said, they absolutely need training on this, or they need more investment on this. And the other thing is, when you're trying to get that budget, you have to convert things in terms that people understand. And the thing that every single person understands is dollars. So we tried to convert everything into dollars in terms of what it meant. Outages, how many dollars lost was it? How many dollars per minute was it? And on certain systems, it could be a lot of money. On certain ones, people would be screaming and screaming and screaming. I'm like, guys, we're losing $10 an hour here. It's just not that important. And it also helps you with budget justifications. I wanted to buy an account management tool for some of our AIX boxes that was going to be about $20,000. And they just kept saying no, no, no. And finally, I calculated what the cost of those systems were for being available. It turned out about $6 million a day went through each one of those systems. And, it wasn't that was profit. That was actually just what was going through in the systems. But it was like, if that's down, that's a lot more than $20,000, especially if someone's asking for this once. And, after that conversation, that PO was signed basically in 24 hours. And so converting things to dollars is a way to kind of really, really understand what's going on, show that you understand what's going on for your business. The other thing about that, I guess kind of the caveat on experimentation, is the cost of retiring something is way higher than introducing it. And so if something's a failure, rip it out early, because otherwise you will be dealt supporting with it and working with it for a very, very long time. I used to say that there's no such thing as temporary in IT, and it's because every time you think something's going to be this quick hack, it does end up staying around for a very long time. So keep that in mind as you're experimenting. Have your playground that's reprovisioned so it just wipes it out if you don't save it, or things like that, because you can get into a lot of technology debt that way, and tech debt's just not something you want to carry around if you can help it. So learning was a very important thing to me, and that's part of these experiments. After I moved to this team, I basically learned a ton of Python, a lot of Ruby, a lot of Puppet. I played with Git for the first time. I was using REST APIs to model things. Since then it was web services, and now people are trying to learn things like Go and containers. And, those are all things that you should be learning as an infrastructure person. You should be trying to improve your development chops or your automation chops. And to me, this was the best part of my job. This was the most enjoyable part, was when I had time to sit there and learn about how to do something better. And, I could show the rest of the guys on the team, hey, here's what's going to go on. Here's what's happening. This used to take 4 hours. It's going to take 20 minutes next time we do it. And everybody'd be like, that's so neat. So that was really the most enjoyable part. The other thing was, to have your retrospectives and have your daily stand-ups and really run like a software development team. I found that the more I was able to model things like software development, the better and more successful we were able to be. And the other thing was, I said at the beginning, people were only requesting transfers off of this team. They were never requesting transfers on. About 2 years in, we got our first request for a transfer to this team, and that was a big milestone. And a few months after that, we had the database team and the middleware team both coming to us and being like, how did you turn things around? This is so much better. You guys are great to work with. And it was a lot better. It was a lot easier to work with when you had kind of defined paradigms for how you interact. We had a lot of self-service. We had a lot of, just ways to make people more efficient. And we were helping them install their own tools. So we weren't just kind of this adversary. We were actually a partner with them in a lot of ways. And so that also allowed you to get, better budgeting, better consideration for promotions for your people. When more people are excited about the work you're doing, obviously the better visibility you're going to have. And so basically, we come back with every month, are we satisfied with how this is working, or are we trying to make it better? And, there were certain things that you're not satisfied for, but the cost to make it better was just so high that it wasn't worth it. Provisioning clusters was like that. I could provision individual servers very easily. Provisioning a cluster took a lot of work. It was difficult. We had to work very hard. We had to test a lot of things manually. You had to pull network cables and make sure, your heartbeats were okay. And a lot of that, sure, we could have automated it, but the cost would have been so high. When you only deploy 4 or 5 clusters a year, automating that just wasn't going to pay off. And so, you had to kind of work through that. So our influence on other teams became a lot larger, like I said. When people start wanting to transfer to your team, it's a good sign. When people are asking, hey, can you help us automate this thing? Can you help us with this deployment? Because, we've seen the success you've had with this other application team. That's good. They ask you for design. They say, hey, can you tell us about availability? We want to fail in this way when this happens, not in this other way. We want it to fail and have a maintenance page on the website rather than just be a 404, things like that. And those are things that we can help with, that our team was able to help with. And again, we kind of became more like automation consultants in a lot of ways as a server team. And I thought that was very much a sign of victory. And so a lot of that was really a long way of saying, go after the cause and not the symptom in almost all cases. Another story I like to tell here of a data center failure was we were doing a 24-hour change window to switch out our director switches, which were basically the storage layer, the equivalent of, like the big switches that everything routes through for storage for Fiber Channel. And we started at 6 a.m. and it was designed to go to 6 a.m. the next day. And this was on a weekend. And about 4 a.m., the last of the servers was coming back online. We were getting its disk already. And we knew this one was going to be a pain. It was a database cluster that was old. And I hand it to one of the admins and I say, hey, this is having an error and it's not seeing all of its disks. It's complaining about it. And he comes back 30 minutes later and me and the other team lead were working on another system that wasn't quite caught up yet. He comes back and says, okay, it's not complaining about seeing its disk anymore or not being able to see its disk anymore. And I was like, hold on. When you say it's not complaining about not seeing its disk anymore, does that mean it can see its disk? He's like, no, but it's not complaining anymore. And so I got to learn that being explicit about things is good, but the symptom that he saw was it's complaining about seeing its disk. To me, the obvious solution was it should be able to see all of its disk. His was, I'm going to make it stop complaining. Which again, solving a symptom, not the root cause. So driving continuous improvement and kind of driving that throughout the entire team is important too, to understand that you're really going after the root cause and not all the symptoms. On the Windows team, we had a person that would close 150 tickets a month, and he was super proud of that. And I stopped him one day and I was like, look, I know everybody thinks you're a rock star because you close 150 tickets a month. Why do you get 150 tickets a month? And he just stopped and he looked at me. And he's like, I've never thought about that. And eventually he realized that he wrote like 2 new Active Directory policies and it was down to like 60 tickets a month instead of 150. And it was just like, these are the kinds of things that we need to be solving as a team. It's focus on fixes, focus on root cause, and, symptoms. Unfortunately, during an outage, sometimes the symptom is what you have to deal with. But in the long term, you want to make sure that you're really addressing why did it happen and not what happened. So kind of to go back, again, I haven't talked about DevOps much. And the reason for that is DevOps, you can read a million blog articles on what it is, or they're going to try and define it and tell you what you're doing. And they're going to give you, you're doing DevOps this way or that way, or you can buy DevOps from these people or download it from these other people. And of course, those are all terrible, terrible things. For me, DevOps was much more about working together to improve as a team. And it was really about the culture. DevOps, they'll talk about CALMs, which is, culture and automation and learning and metrics and sharing. Those are the things that everybody cares about with DevOps. Culture is the most important one because it can lead to working on all the rest of them very easily. If your team and your workplace doesn't allow you to work together and doesn't allow you to work cross teams, it's just not going to work. And for me, this was much more about winning the war on the ground. It was about, I was an individual contributor, or eventually I was a team lead of that team, and I wanted to make that team better. I didn't want to change the entire company. I didn't want to change the entire IT organization. We had 3,000 IT workers at that company in total. I wasn't going to be able to influence all of them. What I was going to be able to influence was my team, the infrastructure for my division, and I was going to try and make that better and have a less terrible time doing it. And I did that through reducing the variability, collaborating with other teams, being honest about the mistakes that we made, experimenting a lot, and then really working on root cause of problems. And I think that that's kind of just the summary of how, people say, I want to go someplace that has a great culture. Well, not everybody has the option to change companies. Not everybody can fly to some hot startup and get a job there right away. Sometimes you're either stuck from where you're at, you choose to be where you're at, you're vested where you're at, you have kids and you don't want to move. There's a lot of reasons why people stay where they are. And the answer isn't jump ship to find a new culture. I mean, it can be. That's an answer. But it can also be, how can you improve your own culture? And that was really what I was interested in doing, was improving the culture of the team I was on so that we were not seen as this toxic group of people exiled in a different building. And by the end of this, we were not in a different building anymore. We were back in the main building. We were working together with all these other teams. And, I was really proud of that team when I left. I was very, very happy to have those people on the team and the success we had. And a lot of it was all about culture. It was about driving the right change and the right behavior. And it wasn't that we had, the best, most technical people ever. It wasn't that we were doing 20 deploys a day. It wasn't that we were measuring, 300,000 different metric points. Like a lot of the DevOps blogs and stuff like that, I'll tell you, we didn't have software as a service, really. We were doing back office IT. And in the end, working together to build a better culture, I think really kind of delivered the DevOps message that we were going for. And so I guess, if you want to take something away from this, that's what I would say is work on your culture internally. And that can help you drive to more success. And if you want to call it DevOps, do that. If you want to call it something else, feel free. Thanks.